Hello everyone. Over the weekend I took part in the Transcend Hackathon by GitLab, which focused around their GitLab Orbit, which is a full code and lifecycle context graph. It used to be called GitLab Knowledge Graph, but now they call it GitLab Orbit. My solution for this hackathon focused entirely on bringing semantic web toolset to GitLab Orbit and seeing how far can we go, with a hope to transcend beyond multi-hop blast radius queries and Orbit natives APIs to the space of reasoning and federating with other knowledge graphs like Wikidata. Briefly, how does it work? We start from the repository of choice, and we can clone it, and then we can use Orbit to index that for us. As a first step, I compared the data model that Orbit has with a kind of my idea of how this could look like, and I use Orbit data model as a seed for OWL ontology that I built on top of that. And this is what's at the core of that, and I also enrich it with some custom axioms so that we can enable some reasoning on top of that. Once Orbit is done indexing, we have the database in DuckDB that stores the data about the code, and then I created R2RML mappings, and that took this code base and via JDBC connection load them into RDF triple format. Just one note, along with ontology, I also created shackle shapes to keep my data validated and constrained. And with that additional kind of standard support, we were now able to query the context graph with Sparkle and federate that with other data sources like Wikidata or DBpedia or any other knowledge graph we wish to query in the same manner. Just to give you a glimpse on the ontology side, this is the code graph and this is the SDLC graph in the ontology view. We can also load it to WebVol tool to kind of have a look at that, and also the other one as well. It's also preloaded with comments from GitLab, so it's an artifact we can have a look as well. And now we can switch to repository, and this is stored in this repository here on the Hackathon page. It comes with some documentation and some examples, but the main thing is probably this skills folder with Orbit semantic reasoning, which you can use locally with GitLab Duo CLI or any other LLM agentic thing you wish to use. There is also agent that I built for this particular project. It's called Orbit Semantic Reasoning. Unfortunately, in GitLab Duo UI doesn't have access to execute commands, so you cannot run the whole pipeline for any repository. So this agent here just provides you with guidelines on how to set up the repository for you locally. I can just ask it, and then it will give us some brief overview of what it can do and so on. But the main thing is to clone the repository and use it locally with the GitLab Duo CLI or as a cloud skill, and it will work nicely with the project there. The other thing I wanted to show is there's also a blog post with some details and some examples. And speaking of example, there is this docs page with freestyle example, which I will show live in a second. And this is the example with the federation of other datasets. So let's have a look first at the blast radius example here. That will be just like a simple example if we want to explore the code base, but just with this different view. It uses, I'm just, I have a screencast here for GitLab Duo CLI, which shows, which you can interact with, and then I ask it to analyze the Network X repository, which is a networking open source library, which would be an interesting case for this, and to find some gut functions and blast radius for modifying them, so we can see what it comes up with. So it will clone the repository if it's not available, and then it will index that with Orbit and use the R2RML mappings and the ontology to analyze it, and we will get a report like that in here. So that's pretty straightforward. You can see the details later on. For the next example, this is the one with the federating other datasets one. We can see that here we are also spinning up the GitLab Duo, and in here I'm explaining to the agent that I want to use this semantic reasoning for Orbit, and also asking it to use the freestyle mode to find out about knowledge graph embedding methods in AmpliGraph. Knowledge graph embedding methods are like algorithms that I'm interested in and that are part of this AmpliGraph codebase. AmpliGraph is another open source project for graph machine learning that I happen to be a contributor in. And I thought that would be very interesting to use Orbit on top of that, and especially with this stack here, that's even more interesting for me. So I asked it to run it on top of AmpliGraph, clone it, index it, and then do the magic, so to speak. And use the federation to enrich the results with Wikidata about those methods. So I'm not only interested in the code base, but like, what if I want to know what's beyond the software space, who came up with this method, which paper introduced that. So hopefully Wikidata will help us with that. And here we can see that GitLab Duo is doing many different setups, running the skill, running Sparkle queries on top of the graph, and then at the very, very end, and I'm fast forwarding here because it takes quite a while, we will get a report at the end with similarly like before, with some insights and also scholarly context, with a table with paper, with a method, a venue where this method was published. So that's something super cool that I think enriches the experience here. And you can find the details in this log over here with specific prompt and the output. So here is the results. We can see that these methods that were found by Orbit were linked to Wikidata concepts, and we can find and see what other information was stored about them, right? And this way we are able to query not only the data that we have in our context graph for the project, but also for all the data is out there, and it's we have available to connect to. So I think that's super cool. Here we have also the queries that were run and defined. We can verify if they are something that is relevant for us, and also like bonus from Wikidata, we found some additional papers that are probably worth exploring, RDF2Vec or other. So very cool. I'm gonna deep dive into this report later on. But for now, that's all from my side. Thank you so much, and I hope to hear from you. And if you have any questions, just reach out, and happy to see what we can build together. Thank you.